Welcome to BBS Pragati channel. In this session, let's have a look at shift registers. So, the shift registers use the sequential logic circuits, that is flip-flops, as the basic element. And here, each bit is shifted from one flip-flop to the other. And there are 4 different types of shift registers: serial in, parallel out, serial in, serial out, parallel in, parallel out, parallel in, serial out. So let's now look at a serial in, serial out shift register. So first you are inputting the data serially, the word is stored, and then we'll see how the data is retrieved. So now let's see at the storing of the data. Okay, let's say that, so there are 4 flip-flops, okay, 4D flip-flops. Q is connected to the second, the first output of the first flip-flop is connected to input of the second flip-flop. Output of second flip-flop is connected to input of third flip-flop. Output of third flip-flop is connected to input of fourth flip-flop. And the data input is given to the first flip-flop. Okay, let's consider that at before time A, all the flip-flops are reset. So Q R S T equals to 0. Okay. Now let's say that we want to shift a word 0 1 0 0. Let's see how it happens. Okay. Let's see how it happens in 4 clock cycles. So at time interval before A, all D inputs are low and T is reset. The 0 in S is shifted to T, the 0 in R is shifted to S, the 0 in Q is shifted to R, the first serial input 0 is shifted to Q. So you have 0 0 0 0. Okay. Now let's say the second part. So in this, let's say that at point B, so this is a negative edge trigger. So again at the next trigger, what happens? The S is shifted to T. So 0 is shifted to T, 0 is shifted to S, 0 over here is shifted to R, and now there is a value 0 which is shifted, which is applied at input, which is shifted to Q. Okay, so now it is 0 0 0 and 0. Now at third clock cycle, at once the negative edge, again at the negative edge of the clock, okay, at the negative edge of the next clock cycle, what happens? You're applying a 1 over here. Okay, so 0 over here is shifted to T, 0 of R is shifted to S, 0 of Q is shifted to R, and 1 is shifted to Q. So you have a high over here, okay, low over here, and low over here. Now at the negative edge of the next cycle, at this point at D, what happens? 0 over here is shifted to T, 0 of R is shifted to S, 1 of R is shifted to, 1 of Q is shifted to R, and 0 over here is shifted to Q. So you have 0, 1, 0, 0. So that's how the word is shifted. The word is shifted serially in 4 clock cycles. Okay. So it's a 4-bit word. So you need 4 flip-flops to store the bits. So it is shifted serially in 4 clock cycles. Okay. Now let's see how the data can be retrieved. That is what is written over here. So we have discussed about the conditions at time A. We have also seen the conditions at time B. Okay. And then we have discussed about time C. And also we have discussed about time D. So we have seen 4 data bits are shifted in a serial fashion into 4 flip-flops. So the 4-bit number QRST is equal to 0100 is stored in it. Okay. Now let's see how the data is retrieved. So here is the shift register. Now the data 0100 is already stored in the shift register. Okay. Now let's see how the data is retrieved. Okay. Now it is 0100 is stored over here. This is at time interval A, we see that 0100 is stored. And if you see at the negative edge of the clock, okay, the first negative edge of the clock, what happens? This is also 0. The 0 at D is shifted to T, okay, and 0 over here is shifted to R. 0 over here is shifted to R. Okay. 1 over here. So this 1 over here. 1 is shifted to yes. And the other is shifted to T. Okay. So it is QRST. Actually it is Q. It is QRST. So this is QRST. Okay. So we see that the word 0100 is stored over here. Now the moment 0 appears over here, 1 bit, the LSB is moved out. 0 comes over here. 0 of this is shifted to R. 1 over here is shifted to 0. Yes. 0 of S is shifted to T. And T is moved out. So this is how it appears. So you have 0, 0, 1 and 0. The least significant bit is retrieved. Now for the next retrieval of the second LSB, what we do? Now there is a 0 which appears over here. 0 of this is shifted to Q. 0 of Q is shifted to R. 0 of R is shifted to S. And 1 of S is shifted to T, and 0 is now shifted out. So the second LSB is also out. So you have HB 0001. Okay. Now at the next cycle, what happens? 0 of the serial data is shifted to Q, 0 of Q is shifted to R, 0 of R is shifted to S, 0 of S is shifted to T, 1 is moved out. Okay. So you have 0000. Now at the negative edge of the next cycle, 0 of serial data is shifted to Q, 0 of Q is shifted to R, 0 of R is shifted to S, and 0 of S is shifted to T, and T is shifted to S, T is moved out. So you have 0000. So the number stored in register is moved out, is retrieved out in 4 clock cycles. So this is all about serial in, serial out, shift register. In parallel in, what do? You input, you store the bits at a time, and so you take 1 clock cycle to store the data, and if it is serial out, you take 4 clock cycles if it is a 4-bit data. Okay. Now if it is parallel in, parallel out, you take only 2 clock cycles. 1 clock cycle to store the data, 1 clock cycle to retrieve. And if it is serial in, parallel out, you take 4 clock cycles to store the data, 1 clock cycle to retrieve the data. So we'll have a look at all those in the next session. Okay. And this is what is written over here. So we have discussed about before time A, value is 0100. At time A, QRST is 0010. And at time B, the register holds QRST is equal to 0001. At time C, QRST becomes 0000. And at time D, it becomes QRST is equal to 0000. That's how the bits are moved out. Okay. So that's all for this session. More in the next session. Thank you. Thanks a lot and I wish you all the best.